Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast, coming to you live from our massive studios here in Raleigh, North Carolina. Just me tonight. Aaron is still out traveling. One of the things that has been really interesting this year has been the rise of this kind of trend called serverless or event-based computing that we've had a couple of shows on here recently, and the shows have actually been probably the top 2 or 3 shows for the whole year. So there's obviously quite a bit of interest out there in the community. First couple of shows we sort of talked about some basics, and we talked a little bit about AWS Lambda. Tonight we're gonna shift it up a little bit. Excited to have Steve Fink from IBM, IBM's distinguished research staff member, and one of the original people working on this new thing called OpenWhisk. So Steve, welcome to the show.
Thanks, Brian. Hello.
Hey, so give us a little bit of your background. You've been at IBM for quite a while. You're actually the first person from IBM to be on the show, so excited to have you on. But give us a little bit of your background. You've been working on some very cool things for a number of years.
Yep. So I work at the T.J. Watson Research Center, which is in Yorktown Heights, New York. It's about 30 miles north of New York City. It's a very big research center at IBM. We have about 1,500 people working in the building, computer scientists, physics, chemists. It's one of the most famous research labs, I think, in the world, and I'm very happy to work there. I've been working there for a long time. I've been working in a group focusing on programming language technology. Over my career, I've done work on virtual machines, a lot of work on program analysis for use cases such as security, language design, and now OpenWhisk, which is, I think of as an application of programming languages to the serverless cloud.
Yeah, it's very cool. So it's, it got announced a couple of months ago. I think it was around February, end of January, February at the just before the Interconnect show. IBM announced OpenWhisk, and the first thing that jumped out at me, because the serverless stuff was kind of getting this buzz, was this wasn't just going to be another like IBM Bluemix service, but you guys were going to open source it. So give us a little bit of the background. You've got a lot of background in open source. What was the general thinking from IBM about why to open source this?
Well, one of the things we've heard in the serverless community is that quite a few people say that they love the technology, but they're very afraid of vendor lock-in, of writing their code for a particular vendor's platform and then being stuck there. So we decided to open source it. That was one of the motivations for open sourcing it, is to try to get people engaged and realize that it's something open that they could run wherever they want and to allay their fears of being locked in. Secondly, I think a very big attraction of these serverless platforms, or at least the way OpenWhisk imagines it, is having a big ecosystem of different service providers, that making it easy to integrate these different providers together. And so we thought by making all the technology open, we're hoping to encourage people to play and contribute to the ecosystem and build up an ecosystem of service providers that can interact with this serverless system. Yeah, no,
makes total sense. And I think at this point, if you really get to sort of one of the core benefits is that somebody else is sort of running this for you. You can just focus on the languages, on the inputs, on kind of the tasks at hand, and you don't have to think about operations. So when you guys were first starting this, what were some of the challenges that you were hearing, either from the programming language community or just IBM customers? Like what drove you guys to say, hey, this might be something that's going to go solve interesting problems for people?
Right. So one trend I think that everybody sees is the need for agility and speed. Development cycles are getting faster and faster and faster, as well as the whole DevOps phenomenon. So I think the whole concept of platform as a service, of lifting up the level of abstraction, letting people focus on their business logic, as opposed to trying to allow them to minimize the amount of time they spend on plumbing, is a big motivation here. So I think what we're going for is a high-level serverless platform where we handle a lot of the virtual machine and containers and load balancing and auto-scaling and security and entitlement and so forth, and free the developer to be able to focus more time on business logic, not worry about infrastructure. Yeah. Some of the other things we were going for. One is, of course, with serverless, people want to pay for exactly the resources they use, and they don't want to pay for any resources they don't use. Part of that picture is also transparent instant auto-scaling. So if I submit 100 requests in a burst, the system will immediately scale up, charge you for exactly what you use, and then dispose of the resources. And then a couple of other motivations. One was, as I said before, the integration story, trying to expose as many event providers and consumers in an easy-to-use ecosystem. And one final thing is we have a pretty heavy focus on the mobile developer. We've talked to a lot of mobile developers who are very happy. Their passion is building cool-looking apps on their device. I mean, the devices these are incredibly fantastic little devices which we all are carrying around in our pocket. And we've talked to a lot of developers who really love working on the device part of their application, but they really don't want to be. They're not enthused by building the back end. They know they need to have a back end to provide the functionality, but that's not what sells their service. That's not what makes it exciting. So for many mobile developers, the back end is sort of a necessary evil, and they'd rather spend more time on the device. And so we are trying to make it as easy as possible for these mobile developers to quickly stand up a serverless back end and let them concentrate again on their mobile platform.
Yeah, no, that makes a ton of sense, and especially the mobile angle, because I know, around the same time that OpenWhisk got announced, IBM made the big announcement with Apple around Swift, around the sort of the programming language for iOS apps, and especially running Swift on the back end. So it makes kind of complementary, makes a lot of sense that you're targeting those kind of folks. Let's talk a little bit about the Whisk architecture, and it's always a little tricky on an audio medium. For anybody who is listening to this, if you take a look at the show notes, there's a real nice diagram that IBM provides. But when I look at some of the things that are out there, it sort of seems like there's three pieces to this. There's a trigger, the thing that the event that actually happens, whatever that event might be. There's an action, which is the thing that runs a little bit of code and does something. And then there's some sort of rule or policy or something that drives how that works. Can you walk us through a little bit about kind of the architecture and some of the kind of the nuances that are in there within some of those different areas?
Sure. Let me start with action. An action is simply a stateless function as an event handler. This is very similar in conception to some of the other competitor platforms out there. So you simply just write some code. That's the definition of your action, and then you can upload it and run it. If you want to get into some subtleties, for example, in OpenWhisk, you can compose actions. You can create chains of actions. So you can write 3 or 4 different actions and then tie them together in a chain, maybe analogous, if you're familiar, to Unix pipes. Okay. And so this is a higher level composition feature which we've added, which we think is pretty powerful. So that's one technique that sort of starts to allow you to assemble more complicated, more interesting applications. Triggers are simply. Technically, a trigger in OpenWhisk is a name for a class of events. So if you're familiar with pub subsystems, sometimes this is called a topic. It's simply a tag by which you group a bunch of events and can name them. Okay. Usually what you do is you connect a feed to a trigger, so you can take any stream of events coming from any source, and the system provides APIs that allow you to hook these up. So you can say that the stream of events coming from wherever, from a queuing system or from a database notification mechanism, or even just HTTP posts that people do to the system, get fed to a trigger. And so there's different ways to inject events into the system. As far as rules at the platform level, a Whisk rule is a very simple entity. It's simply saying when this event happens, invoke this event handler, or in our terminology, when an event of this trigger happens, invoke this other action. Using our primitives, you can encode more complicated rules on top of it. So, for example, if you're familiar with ECA, or event condition action, so I can encode a condition as an action, which produces like an if statement, which produces its input if it's true and otherwise produces null when it's false. Using this together with the sequencing, the composition I mentioned earlier, you can now build a rule which says if this event happens and these conditions are true, then invoke this action and so forth. So that's another subtlety, I guess you were going to.
Yeah. One of the other things that jumped out at me, and I think anytime something new comes out, people tend to compare it to maybe what exists in the market. And what was interesting to me when OpenWhisk first got announced, like Amazon has Lambda, and when Lambda came out, they said, well, we only support this programming language. I think initially it was Java or Node, and you guys kind of took it a step further, a couple of steps further. You supported, just sort of Docker containers as being an input, right? So you could have, instead of just a simple event, you could have essentially something that would say, go trigger what could be a much more complicated, sort of processing task as well. Is that something you guys were actively like, hey, we don't necessarily want to just limit ourselves to a language or something simple. We want to start thinking about more complex scenarios?
Yeah, that's absolutely true. And so the way the Docker actions work in OpenWhisk is if you can write a statement in a Unix shell which consumes standard input and produces standard output, effectively you can wrap this in a Docker container and present it to Whisk, and we'll manage it as a stateless action. The real use cases for these are, well, one really compelling set of use cases for this is, suppose you want to use some highly tuned C library from wherever, from GitHub, in your action, maybe a highly tuned video processing library. So you certainly don't want to rewrite this library in portable language like Node.js or Python. On the other hand, what you really want to do is just build a binary, upload the binary, and then invoke it and manage it as an action. The difficulty with that, of course, is the portable environment, since C binaries are not really relocatable or transportable across different systems. So what we've done is we've taken the Docker standard as a way of providing a architecture-independent representation of a program, which is simply a Docker container, and you can describe it by a Docker file. And so we allow you to do this, and then it allows you basically any sort of binary or anything you can imagine that you can encapsulate inside this Docker container, which is just about anything you do on Linux. You can just present it to the system, and we'll manage it as a stateless action.
Right. So that's at least initially going to get people around all of the, hey, do we support this language, that language, the other? You can kind of always use Docker as an entry point for the system, which is very cool. So, one of the questions that we get, and you guys, we may be too early in the cycle of how this is all coming together, but we've heard a number of conversations where people are really saying, there's a number of aspects that the sort of serverless event-based stuff is very interesting, and you highlighted some of them. They run in a public cloud, so you get those benefits. You're going to pay for kind of exactly what you use. You're not buying a resource and then you're going to pay for whatever you use or don't use. You're using exactly that. Does auto load balancing, auto scaling, kind of, sort of the paths that you really wish the platform would do. And the question that comes up is, I think they're starting to say like, hey, is there a reason I would want to, write applications any other way? Which is, kind of always what happens in our industry. We go as far extreme as we can. What are you guys seeing as people are starting to play with the system, get used to it? Are you finding a certain category or class of applications kind of fit in this, or a certain mindset, or are people trying a little bit of everything?
I think people are trying a little bit of everything. I can give you some examples of some of the cool things people have been doing.
That'd be great.
So we've had a couple of really cool applications done around video processing. And in fact, if you go to YouTube and you search for OpenWhisk, one of them is called Dark Vision and one of them is called Skylink. These were some cool. So people posted the source code on GitHub, so you can just look at them. So they're both video processing type applications. The first one, what makes them really cool though, is they use IBM Watson image processing libraries in the chains. So they do things like, they take, as I said, their video processing. They take frames and then they send them to various Watson services to do facial recognition or image tagging of images, and some other cool things. So the dark vision one is really cool. It sort of shows you how to use a serverless pattern to enhance a image sharing site. And the way it's structured is it uses a database as a mediator. So if you think of a model view controller type architecture, if you think of the model as residing in a database, and then they set up Whisk rules that say whenever the model in the database changes, they're going to go off and do some actions. And what they do is they grab images which are dumped in the database and send it off to Watson services to generate tags and do facial recognition, and then dump those results back in the database. So I think it's a really nice pattern of how to do things with serverless, in that you can write sort of a traditional web app front end which interacts with a database, and then you can add value on services which simply communicate through the database through triggers and then write results back into the database. And it's a very nice example of an event-driven architecture, because you can add more and more listeners independently to changes in the database to do more action. So if I want to add a new feature, a new kind of processing to this application, I can simply install new rules which listen to the same change events and fire off different actions and so forth. And you get all the benefits of transparent autoscaling and everything like that.
Yeah.
So the dark vision one is really cool. The other one is the Skylink. It's a similar flavor technically, but this one is really cool because it's hooked up to a drone, a little commercial quadrocopter, or whatever you call it, four-blade helicopter. And if you go look through the YouTube videos, they've hooked up through the software which controls this quadcopter. There are ways to hook in with API hooks, and they use that to basically dump the video from the quadcopter into a database and then apply the same sort of technology and then present it back to the dashboard which drives this quadcopter. And so you can get real-time image analysis of the terrain that the copter is flying over, and ask Watson to give you information about what it sees about these images. So I'd encourage you and your listeners to go check it out on YouTube. There are some really nice demos along those lines.
Okay, very cool. Yeah, we'll find those. We'll put them in the show notes and link to them. I mean, as you're talking about the idea of, lots and lots sort of expanding listeners into a database, and as things come into the database sort of standard from the application, you have the ability then for these sort of interesting data feedback loops where, depending on some internal group or some internal function, their context, may be able to take that change, go do some actions on it, do some processing on it, and put whatever those things are in their own specific context, and get some pretty interesting feedback loops about what's going on, like in the financial markets or in weather patterns or all sorts of interesting things like that. So yeah, that's a very, very cool use case. So what are you seeing? Obviously it's out there, it's open source. We talked about that, why that's important. At least early on, what are you seeing from people? Are you seeing them wanting to contribute much more in terms of kind of the core, engine that deals with triggers and actions and events and so forth? Are you seeing them mostly saying, hey, I like the fact that I can kind of run it anywhere, but I'm doing most of my, experimentation out of the edge, in applications, in things? And where are you seeing interest from people in wanting to work with you guys?
Yeah, so we've seen some of both. We've had some people jumping in to talk about the core system, but I would definitely say we've had more around what I would call the edge or the ecosystem. So, for example, we've had, someone built an SDK in NPM, the OpenWhisk NPM module that came out of open source,
okay.
Or someone built an integration with Node-RED. And I would expect to see, we've had a number of conversations about people who want to expose their own services into the OpenWhisk ecosystem. I think that's the easier way to get involved, is sort of a lower barrier to entry, to be kind of a user or a library writer and to contribute that way. Eventually, I expect or I hope that more people will get involved into the core system and start to really hack on the core components and microservices. I think that's just a little more scary, a little more technology that needs to be learned in order to really get up to speed on those parts of the system.
Yeah, no, absolutely. What if somebody came to you? We're starting to see these little kits. A lot of times, people are talking about using some of these event-based systems for stuff like IoT and small remote devices and so forth. We're starting to see kits pop up here and there from different hardware manufacturers and different people that are sort of starter kits. Are you guys doing anything? If somebody came along and said, "Hey, what's the best way to get started? What's an easy way for me to kind of go do some things?" Any tips or things that you've seen so far that are, sort of great first steps for people?
Well, I would say, as in the big picture, an easy way to get started is we distribute a lot of sample apps and tutorials, and even like the applications I was speaking about before, the video processing. An easy way to get started is just to download those, take a look at them, and then see how they go. As far as the IoT space in particular, which you mentioned, we've been looking at that quite a bit. I would say the first concrete step in that space was the Node-RED integration, because Node-RED, I don't know if you're familiar with that, this is a very popular platform for coordinating activities in IoT devices, and it can run on many different IoT-like hardware, like Arduinos and Raspberry Pis, and it talks over this very lightweight messaging protocol called MQTT. And so that's one very good way to start to look at the IoT space with Whisk, is to use the Node-RED integration. Okay. I expect we'll have a native integration with MQTT as a messaging format coming down the line. And so that'll be another way. And we'll see what happens. I expect there'll be lots of growth in this. And one of the best things about, opening it up is that people will come up with things we haven't thought of, and ways to use the system, or we've already seen quite a bit of that. And so that's one thing that's really exciting about putting something out there, is just to see when people come up with something you hadn't anticipated. That's just awesome. Right.
Now, will you be at the Serverless conference that's coming up here in a few weeks right around your neck of woods out in, I think it's in Brooklyn?
Yeah. Yep. I'll be there.
Okay, cool. Are you speaking, or are you just in attendance?
I'm speaking. I'm giving a talk along with one of my colleagues. Actually, the dark vision video processing I mentioned before, we're going to be demoing that at the conference. Very cool.
Very cool. Well, listen, sort of last question. We've got a number of links, the GitHub links, source code, IBM OpenWhisk on Bluemix. Where can people potentially, find you out and about, if you're at conferences and stuff this year, or, what's a good way for people to maybe get in touch with you or your team if they want to talk about this some more?
Sure. There's lots of different ways. For me personally, I'm at SJ Fink on Twitter, if people wanted to message me there. If they Google me, Stephen Fink with STEPHEN FINK, IBM on Google, you could find me and you'll see my email address, and you can contact me that way. Through the Bluemix offering, if you just want to give general feedback or you find a bug, there's a feedback button right there in the UI, so you can just click that button and send feedback. We have a Google group associated with the open source project. I would also encourage everybody out there, if you have a problem or an idea, don't be shy to go to our GitHub project and talk to us over the issue tracker. We do a lot of our design discussions and certainly bug discussions through the issue tracker on the GitHub repository. And so that's a great way to monitor the conversation that the development team is having and get involved.
Yeah, no, it's a very active community already, which is great. It's only just a couple of months old. Well, listen, thank you so much for this. This is it's like I said, this has become a topic that's really piqued the interest of a lot of our listeners. I know they're all trying to kind of figure out where should they start and which platform should they choose and so forth. I think it's cool that you guys are making this open. You've got a number of options that people can kind of get started with. So this has been very good. Stephen, thank you so much for the time tonight and the insight into what IBM's doing. And hopefully we look forward to talking to you again sometime soon. See how this is evolving.
Great, it's my pleasure. Thanks for having me.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.